Okay, so let's talk about interval notation. This is a really commonly used way in mathematics and sciences for ways of describing uh, things like the solutions of inequalities, all of the numbers between two other numbers. So, for example, if you see these closed brackets here, square brackets, around two numbers and it looks like an xy point, what that really means is the set of all numbers that are between a and b and including a and b. So you could draw it on a number line here like this. It includes a and it includes b, so I make a solid dot for that, and then just fill in all this stuff in the middle with a line. And so that's what the square brackets indicate, is that you are including the endpoints. And by the way, for this to make sense, your A must be less than B, or if I read it, I just wouldn't know what it means. So you could also write this as an inequality. You can write it as values of x that are less than x must be greater than A, and x must be less than or equal to B. Sorry, greater or equal to A and less than or equal to B is what all those numbers in between there are. Okay, so now what if it has parentheses like this, like a regular old ordered pair? It looks like an XY pair. In that case, this is indicating that it does not include the numbers A and B. So it includes all the numbers in between, but it doesn't include the A and it doesn't include the B. And so you could write that with inequality notation as just x is less than A and x is less than, or I said that backwards, x is greater than A and x is less than B. And we could also write it with infinity on one side or the other. This would represent the set of numbers between A and infinity, not including A and infinity. What that looks like on a number line is it would include everything all the way out here, and you just shade the arrow to show that you're including all those points all the way out there. And infinity is just a concept which represents all the way out to the right on a number line, farther than any actual numbers, but we can't include it in the set because it's not exactly a number. And we could also write this as an inequality, just as x is greater than A, with no upper limit. X doesn't have to be less than anything. I guess you could write the less than infinity if you want, but what's the point of that? You already know that x is less than infinity because it's a number. All right, what if you have infinity on the other side? Well, that would mean you have to talk about all numbers greater than infinity. And in order for that to make any sense, this would have to be a negative infinity out here. And then you could have like a number b here. What that looks like on a number line, what this looks like on a number line is as follows. It would include everything to the right side of b, but because this is a square bracket, it should include b itself as well. So it includes a b, so you make a solid dot to show that, and also shade everything between there and negative infinity, like so. And how would you write this as an inequality? You just say that x is less than b. Okay, here's another example. I think you should try this example yourself. I'll show you the answers in a moment, but here's the point to pause it because I'm going to start spoiling the answers for you right now. Okay, so for part A, we're saying x is greater or equal to 3 and less than 6. So what that looks like on a number line is we want to include the 3 there, not include the 6. So you leave that as an open circle. And so it looks like that on a number line. As an interval notation, you can write this as the lower number always goes on the left, and the upper number always goes on the right, but we're not including the 6, so you use round parentheses for that. And for part B here, we have x is greater or equal to negative 9. So on a number line, we're going to shade that with a solid dot at negative 9. And shade everything to the right of that. And how do you write that in interval notation? Well, we're saying that x is greater or equal to negative 9 and less than infinity. That's like the farthest you can go to the right. So we're going to write that as a greater or equal to negative 9 goes like that. The right endpoint is infinity, so it looks like that. So that's the interval notation for that. For part C, this is a little different because it's broken down into two parts. There's the less than or equal to 1 part. So let's say 1 is here. We're going to include 1, and x can be anything over here. And then there's also the x is greater but not equal to 4 part. That includes all of this stuff. And so we can write this as two separate intervals. That's the interval on the left. Here's the interval on the right. Now, and yeah, I'm using negative infinity as the left endpoint because that's like as far to the left as you can go when you're talking about numbers less than 1. And the furthest to the right you can go is to infinity. Now, to show that you're talking about the set of numbers that are in either of those, so like for example, if x is 0, that makes this statement true. 0 is less than 1 or greater than 4. It's not both, but if it's at least one of those, it works. So to talk about the collection of things that are in one or in the other, you use this union symbol. That is a mathematical symbol for taking two different sets of numbers and then grouping them into one big set. So you can talk about that set as if it's like one thing. All right, let's look at this one. I'm going to start by trying to draw a picture of it. Okay, there is the set of numbers between negative 8 and negative 5, including negative 5, but not negative 8. And then over here, we have numbers between negative 1, including the negative 1, but less than 3. So we could write this as two intervals. There's the negative 8 up to negative 5 one, which looks like that. And then that's combined with this other interval from negative 1 to 3, including the 3. And there is the only way to write that in interval notation.